All right, thanks to everybody for joining today. Hopefully everybody is staying warm if you're in the continental US. For those that aren't, lucky you. Today we have a couple of repeat speakers. Elie and Jorge have given a couple of talks over the past couple of years about their projects that they've been working on. And this is one that I've been involved with for a couple of years as well. They're going to be talking a little bit about their virtual lab infrastructure that they created for an NSF grant, and it's operating right now at the University of South Carolina. And they're going to talk a little bit about how they're using this to train, teach, and perform some research on network and cybersecurity topics. So, Jorge, I think you're going to be presenting, so I'll turn it over to you.
Thank you, Jason. Good afternoon, everyone. I'm Jorge Cricigano. I'm here at the University of South Carolina, and the co-presenter is Elie Kfoury. He will be adding some information. He's a PhD student working with me at USC. Some information that we will talk about, for example, virtual labs, material, what our students are using, can be found also online in our website. This is the agenda. I will start with what was our initial motivation and the cloud that we deploy at USC. Shortly, the process of how we're designing virtual labs. Then the libraries, the importance of having partnership with the industry, and then how we are extending. This is further extension of the original project. We are extending this to a distributed cloud and some other topics related to research. The motivation is because first, we are an IT program. I'm in the Department of Integrated Information Technology at USC. This is an academic department, and we teach IT. And IT is more practical than theoretical. That's what the ACM, the IEEE says. And there was a need back in 2018 when I joined this department. We didn't have any space here at the University of South Carolina to put physical laboratories like a networks lab, cybersecurity lab. In addition to that, as Jason mentioned at the beginning, we were interested in training a platform that was scalable for training IT, for training topics such as science DMC, perfSONAR, IT topics in general that are useful for students and learners in general. So the question is how to include authentic practice, professional tools and platforms, access to computing technologies with these challenges. Again, limited labor, limited space, and a way to make it scalable. So we deploy a local cloud. The cloud is available through any browser. So if somebody wanna run a experiment, just use our regular browser. And this is what is, from the administrator point of view, what is holding the whole system. We have more servers, but I will talk later about the distributed cloud, which is an extension. The original cloud was composed of these 3 servers, host 1 through 3, and they run all the virtual machines that are used for training. For example, if we want to create a scenario with perfSONAR nodes communicating with each other, so those are the virtual machines that are being used for that scenario. We have a management server on the right side, and this is the one that is running the virtual machine for management. Essentially, it's vCenter. For those who are familiar with virtualization, vCenter is a management application from VMware. Then there is a management software that is proprietary, and all this is running in ESXi. So we have an agreement with VMware, so we are running this ESXi for academic purposes, teaching purposes. And they are running on physical servers. This is a virtual environment. All this is on campus. This is attached to the regular campus network. Is a /24 network. That means we have 254 IP addresses available for pods. I will talk much more about pods later. But basically, whenever there is a learner that is connecting to the system, most likely is going to need an IP if that learner is requiring to use live traffic to and from the internet. We found out with around 250 IP addresses are enough, because typically students come and go. They are not all at the same time, and classes, large classes are 50, 60 students. So that's a number. It's not a problem to expand that to a for example, a /16 if we want. But for us, /24 works very well. I have to give credit to our partners, Network Development Group. This is a really great partner for us. We have projects in common. One of these is this one, creating this local cloud. The specifications, the management server, 20 cores, 4.8 terabytes, and 128 RAM is enough. For those servers that are for holding virtual machines for virtual labs, what we found is that memory is very important. Storage, we use linked clones. So storage, we make sure that to optimize any storage that we have. I will talk more later. And the CPU cores is also important. Typically, one virtual lab environment could consume 1 or 2 cores. There are some for research purposes. We have some that are used many more cores. But in general, few cores are enough for a virtual environment, for a virtual lab experience. I will use the perfSONAR pod as an example. A virtual laboratory experiment requires a pod of devices, or simply pod. That's what I'm referring to as a pod. Example, if we want to learn perfSONAR, we might want to recreate an environment where there are several networks. I should say multiple networks. For example, 3 networks, network 1, network 2, network 3. So we can create, for example, a mad dash. We can do some tests and learn about perfSONAR. There is a need for a client if we want to teach how to use the graphical user interface. So a learner will connect to the servers and or to the routers or somewhere else, and it will create the dashboard. So this is the pod design. So the first step, whenever we create a virtual library, we have to come up with the pod design. What are the devices that are needed? And then we have on the right side in this slide, the labs. What can we match with this pod? This is what we want to do, the labs. And typically all the labs, in this case on the right, should be able to run with the equipment that we have on the left. For perfSONAR, we found that these labs are a really good introduction. For example, the graphical user interface, metrics, the command line interface, the PH scheduler, mad dash, etc. With a little bit more of details, if we count the number of networks that we need to create this scenario, we have 4 networks, 3 local area networks, plus a point-to-point between these 2 routers. Then there are 3 servers, perfSONARs 1, 2, and 3. 1 client, 3 routers, connectivity to internet, total of 7 heterogeneous virtual machines. We found that in our cloud, creating such scenarios with multiple VMs, multiple networks, heterogeneous virtual machines, because we use, for example, Linux, sometimes we use Windows, sometimes we use virtual machines from some industry partners, for example, Palo Alto Networks. So it's in this local cloud, it's easy to create these environments. If we try to replicate that in a public cloud, I'm not saying that it's not possible. It's possible, but it's just much harder. So a little bit more details about this perfSONAR pod. If I'm teaching a class or we have a training event where we have 100 learners, the idea is that we would like to have a virtual environment so that all the pods are identical. That means that the 50, 100 learners should be able to log in at the same time, should be able to have the same IP addresses in the topology, exactly the same topology, exactly the same lab manuals. And certainly we're able to do so because we create this environment. Each pod is like a sandbox, even though if there is a need for live traffic to the internet, we can easily create that. If that's the case, we just make the last device before hitting the campus network. This connection to the internet is really for us, the campus network connection. We have a NAT box in the border, and all this traffic here is living as one single IP. There is a master pod, and then creating linked clone from that master pod is very easy. In fact, it takes a few seconds. So creating a pod, having 100 copies of that pod it takes the same amount of effort. So it's very scalable. With these 3 servers that we have, we found that we can support with one server, typically 100 pods if this is not a pod that is very consuming, resource consuming pod. So the capacity is really good for the size of our number of students, our classes, our training events. Since 2018, when we started this project, we received the grant to create virtual labs on high-speed networks back in 2018. I believe was October 2018. Jason referred to that project. Jason is one of our advisors in this project. We created several lab libraries. For example, one library is about the tools and protocols. Students who want to learn about iPerf or how to use NETEM, how to create emulated wide area networks, TCP, different flavors of TCP congestion control. And these libraries are created as books. So all the theory plus step-by-step directions to learn these tools are in the lab manuals. Fairness, router buffer size. There are experiments that showed what is a buffer bloat, how to mitigate buffer bloat, several topics. Active queue management, AQM. The type of topologies I showed before, the perfSONAR topology, that was the topology, the pod for labs related to perfSONAR. In this case, labs for network tools and protocol, there are a variety of topologies. This is one example. Lab 14, routers buffer bloat. Here we have a server, destination, 2 source servers. So traffic will be in the direction of H3, we will have queues being formed in the output interface S1 ETH2. Something else that I'm looking here, the rates that we're able to handle in these emulated scenarios are up to 40 to 45 gigabits per second. Okay. Other lab libraries that we develop, Intro to SDN. We just finished this lab library about SDN, VXLAN, OpenFlow, how to interconnect legacy networks. For example, a network that is running BGP with an SDN network, and some other protocols, VPLS, ECMP, how to achieve ECMP within an SDN network. To give you another topology example, and by the way, within a lab library, let's say SDN library, the topologies don't need to be the same. So lab number 8, we want to show interconnection between legacy networks and SDN networks. So we'll have one topology. If we have lab number 4 about OpenFlow, maybe it's a different topology. For lab A, this is an example of legacy networks. Autonomous System 200 and 300 are legacy networks running BGP routers 2 and 3. And then we have in the middle the SDN network. Those are switches that are managed by this central controller C0. And another observation, now that I'm seeing this topology, is that for all these labs that I'm talking right now, we use open source software. The software that we use, the router that we use is FR routing. The controller that we use for the SDN series is ONOS. I'm trying to remember the switches. Elie, I don't know if you remember the switches, but I think maybe OVS.
OVS switches, yeah.
OVS switches, yes. And then standard protocols, like in this case, connecting legacy network with the SDN, they will use BGP. Another, this lab series, by the way, that was originated after a technology exchange conference in 2019 that we had a meeting with Jason, and there was a need for a BGP lab series, and it ended up being very useful. I use for my classes. There are some other institutions that are using, some community colleges. We have another project with community college, so they are using this lab series. Is all about BGP. So from the very introduction, the very basic of BGP, the student has no knowledge at all the way to route reflection, even multi-protocol BGP. There is another lab series that is advanced topics on BGP and MPLS, more modern technologies, Ethernet VPN, layer 3 VPN. This is not that new, but it's more advanced. Segment routing. There are several libraries. Open vSwitch, that's another library that we are finishing. Hopefully this will be distributed. We distribute, we are creating a distributed cloud that any institution who is interested in using this could use this cloud. That's something that I will talk a little bit later. But the other way to use this library is by installing them. Installing them in local clouds. If an institution has a local cloud, it can install this. And there is a channel of dissemination through this partner that I mentioned at the beginning, the Network Development Group, NDG. perfSONAR, Zeek Intrusion Detection. I think that's it. So around 7 or 8 lab libraries. That's what we developed so far. I think there are 5 that are already being disseminated. 2 or 3 that are being finished. We have one more, OSPF, I believe, is the one that we plan to finish by the summer. Some comments after 3 years of experience developing this. What are some advantages, in my opinion, my experience, using a private local cloud? Allocation of resources is very easy, very granular allocation of physical resources. What that means is CPU, cores, also RAM memory. We test these virtual labs and we notice, is there a need for more CPU? And it's very easy to make these modifications. Custom pods, very easy to create custom pods in this environment. Is Graphical something that is very useful for, especially for those students that are starting, is the graphical user interface. Simply by clicking on a device in the topology, an interface is open and the user can configure that device. We found that it's cost effective when used extensively. I think we're, if I remember well, about over 20,000 labs per year. That means lab experiments, and each lab experiment on average is about 4 hours. So the cost of deploying such system or that number of labs in a public cloud probably would be much higher than the total cost for us. Presentation layer for pedagogy, I already mentioned. Topology is graphically presented to the learner using a regular browser. No need to install any software. Time sharing, the owner, we control who can access the resources, easy to implement time sharing policies. Our system, the distributed cloud, I will talk later, is being shared with other institutions. So the functional realism virtual labs have the same functionality as real IT hardware in real deployment and execute the same code. We're using, we're doing emulation, we're not doing simulation. All these pods devices in this pod can receive and send real traffic, interactive network traffic from the internet or from other devices within the lab environment. In 2020, again, this project started in 2018. So 2018, we deploy the cloud. The number of labs that were completed, that means one lab means that a student or a learner is in front of his or her desktop completing the lab for about 4 hours. So in 2018, we used these 690 lab experiments. Last year, 2020, 6,000. So the trend, what I'm seeing is at USC, we start using this for a few classes, and then we keep adding more and more classes. It's a very easy to use. Once the instructor start using it, likes very much because basically it's ready. The system is ready. Is easy to prepare a lab rather than having a physical lab. So before I change subjects, what I will do is I will show exactly how the platform look like. So this is from the administrator point of view. Pods, so the pod infrastructure, all the pods are here. The perfSONAR, so what we would be able to see if some learner wants to or start using a pod, we will see this pod being active. Again, I mentioned we have some partners with Palo Alto. We can use their virtual machine. Elie, for example, is using research on P4, so we have deployed some P4 pods. I think he's using also some Tofino models. Tofino is the chip that is used by, was created by Barefoot Networks. We have the model, so we can run the model of Tofino in our cloud for research purposes. And there are some others, the Zeek, etc. Back to the top. Virtual machine infrastructure. So we have all the virtual machine in the system. The inventory is here. The host, I mentioned at the beginning, the 3 hosts that are hosting the virtual machines. And so that's the interface from the administrator point of view. So if I switch and pretend to be a learner, what I will have is an interface. I want to schedule a lab. In this case, this student has 2 classes. Let's go with this one. perfSONAR, lab, let's say lab 3, and the timeline I will make available immediately. 19 for almost 2 hours. So it's immediately because the start time is 2:28. So I enter the lab is being created. So this shouldn't take more than a few seconds. Again, what the system is doing is creating or is booting up all the virtual machines of perfSONAR lab. Those 7 virtual machines that I showed before, and all the interconnection, the 4 networks interconnected to the internet. So that's it. Lab manual is here with the direction of the lab. Back to the topology. This is still booting, is a perfSONAR node. All right. Now, partnership with the industry. Again, in my role as a faculty in IIT, Integrated Information Technology Program, I also like to show my students about some professional tools, what they might find in their careers and their positions. So the IEEE and the ACM state that IT curriculum should emphasize learning IT core concepts combined with authentic practice and use of professional tools and platforms. This is a document that that guide any IT program in information technology, IT program. So what we did is back in 2018, 2019, we partnered with some companies, VMware, Palo Alto, Cisco, Juniper, some others, and we can get the virtual machine. For example, this is a pod that we created for cybersecurity. And we are using here 2 virtual machines from Palo Alto Networks. So by having these partners with Palo Alto, we get these virtual machines, firewalls 1 and 2, connected to the internet, and we can do a lot of experiments and teaching labs. So that's the advantages of having this partnership. Some other advantages, students can get some additional credentials. I will jump this 2 slides. So far, what I was describing is the local cloud at the University of South Carolina. Now, that was 2018. The project was going really well. And we started to receive some requests for using the platform by other institutions in South Carolina. So in 2019, we prepare a proposal with partners in North Carolina to expand a local cloud. So our partner in North Carolina, Stanley Community College. This is a community college in near Charlotte, about an hour from Charlotte. Our partner from the Network Development Group and University of South Carolina. And what we said is, what if we combine the resources in our data centers? So at USC, we have some servers. North Carolina, also another set of servers. NTG has some servers, data center in Illinois. And the idea was to combine these resources and create this distributed academic cloud. And this academic cloud would provide virtual lab services to other institutions in North and South Carolina. So we submitted this proposal. This was an advanced technological education proposal. The goal was scalability using the resources available on campus networks. And this has been very successful. We deployed the platform in 2020, this distributed version. And it has been used today by community colleges, universities, high schools, some other institutions. Fort Gordon started to be used more and more. So we are providing services to Fort Gordon. They are using for cybersecurity and virtualization courses. In particular, is this more useful now because of COVID and the environment that is ready for a virtual environment. So the big picture of this distributed cloud is we have data centers in South Carolina, that's USC, Stanley Community College in North Carolina, NDG has a data center in Illinois. And these are servers hosting virtual machines. I just show one server in this graph. However, we have 3 servers devoted to this distributed cloud. Stanley Community College, I believe, has 5 servers. NDG has 5 servers. Overall, we have near 15 servers. And with these 15 servers, we are able to serve over 100,000, I'm sure over 100,000 learners in 2020. The system is orchestrated from North Carolina. There is a software by NDG that is running this distributed cloud. Another nice feature is that some virtual labs are running in Stanley only, for example, or Stanley and NDG. That means these pink virtual labs. This is an example. Let's say this is virtualization. From the learner might be in South Carolina, and from the learner, everything is oblivious. That means that the learner doesn't know where the pod he or she's using is located. It might be in North Carolina, it might be in South Carolina, might be in Illinois. Another observation now that I'm looking at this is that we just extended to a 4 site. There is another 4 that was extended in January 2021. That was just a month ago in Idaho. So we have a 4 node running. In the news, so VMware is one of our partners, is giving us the ESXi and some other tools. These are our partners from North Carolina. This is the data center in North Carolina. So I will stop here. I will let Elie talk about what he's doing related to research and how he's using the cloud for research purposes.
Thank you. So beside using the NetLab and the cloud for running some labs and teaching students, we've seen that it can be very useful as well for conducting research because you don't want to run everything on your local machine. And even if you have a server, sometimes you need to change an operating system. Sometimes you need to allocate more resources for a certain experiment. So we found out that this whole environment is really useful whenever we want to conduct some research and we want to parallelize things in particular. For example, here we were running an experiment to test the performance of different flavors of congestion control, of TCP congestion control, namely cubic, BBR1 and BBR2. And we ran over 100 different experiments. Each experiment we had to run it for I would say more than 10 minutes. And the idea is we need to average the results multiple times. And to be able to do that, really, we need to explore parallelism. For us, it was very easy to use this platform because it was a matter of saying, okay, we need this amount of devices. We run a script. This is the script that will execute the experiment. And we just wait, and all of them are running at the same time. Once we have the results, then we can analyze them and, of course, average them and use them later to for further analysis. But basically, the idea is that we were able to do a lot of experiments and all of them were running in parallel. So that gave us more flexibility and allow us to have results at a faster time. With respect to pod reservation, we can have each pod running one experiment. And the nice thing about it is that when you have this kind of isolation of resources, we are sure that if you run a test and you are bound by the resources, it's not affecting the other test. And this is very important, specifically when we run experiments on those congestion control, since the CPU performance will affect the results. So isolation is also, we found it very important. Next slide, please, Dr. Jorge. Also, what we've seen is that whenever we want to conduct a certain research and we are implementing a new idea, most of the time we will be working in groups. For example, in our group at USC, we are 3 working on research. And sometimes we need to share the same environment. What we've seen is that we can use also this platform to, let's say someone will run a pod, will make a reservation, show the topology that he's doing. And at the same time, other researchers can see what he's doing and they can as well interact with the system. So for example, you can see here we were running an experiment while using the Tofino model as a software switch. We were trying to see the interaction with legacy devices and P4 at the same time. And really what we've seen is that you can start this whole environment. You can have, let's say, a big screen showing several terminals. One user can work on the code phase, so can write the code. Other can work on the debugging phase. So, in short, we were able to parallelize things at the same time. We were able to collaborate in that specific environment. And although there are other clouds that are publicly available that allow you to do that, but for example, here, we needed to use some specific software that you cannot just deploy on a public cloud. So that was very interesting and very useful for us. We implemented projects such as in network security using P4. How can we use P4 switches to analyze the traffic and check whether we have an anomaly and an intrusion detection. And also we've seen how we can use P4 to offload the voice over IP traffic from the general servers to the switch. And also we recently started exploring the idea of using P4 switches to analyze traffic passively in a legacy network.
Thank you, Elie. I will add something. You mentioned the collaboration, something that I didn't show in the platform, but the platform allowed teamwork in the sense that a student can reserve a pod and other students can join the same pod, so they are in the same environment. So let's say this is the environment, this is the client. So 2, 3, 4 students in the same group can be using the same pod simultaneously. So that's really useful. That's another feature that we're using a lot, I see a lot, especially when they are working on the capstone projects. So, Elie, do you have any additional comment?
That's it from my side. If there is any question.
All right. With that, Jason, that's our presentation.
All right, well, thank you guys. Really interesting stuff. It looks like there's been a lot of upgrades since the last time I did a workshop with you. So I'll open up the chat room here for questions if people have any. I've got a couple of quick ones that I just jotted down here really quick. So in your sort of list of exercises, have you thought about or are you planning on trying to do anything with IPv6?
We're open definitely if our advisors indicate that IPv6 is needed. Absolutely, we're open to do so.
Okay. And another one that I was just thinking about as you were doing this, since most of these are sort of meant to be within a single pod, and you have the multiple data centers there, is there any sort of use cases where you're trying to be able to link pods that may be running at different data centers at any given point in time, or the emulations that you've sort of created? Is that enough sort of delay and latency and things like that to be able to do them still within the virtual environment?
Yeah, that's a really good observation. The answer is we were thinking about that, linking the different data centers for educational purposes. And the idea was to create pods on P4 using real Tofino switches. We did not do yet that, but in fact, we have a proposal that is there, and hopefully we will be doing that soon. Regarding the delays, latency, we are able to recreate latency delay using NETEM. At least for educational purposes, NETEM is really instrumental, really useful. So with NETEM, we're able to get any delay, latency, packet loss rate for the students.
Okay. All right, we have our first audience question. Shafak wants to know, what is the process for other universities to leverage this platform for their own labs and research? Do they have to also work separately with industry partners?
If the answer to that would be, we are creating this academic cloud, and we're making, because we're under NSF, and we're very grateful for NSF. Many institutions are using under this project, just contacting us, and we can give access to the platform, run classes in our platform. The distributed cloud is even easier in the sense that you are logging to a general portal. It's not USC portal, and just create the course and use the material. Now, there are some material that require a specific partnership. For example, all the lab libraries that I mentioned at the beginning that were made with open source, that's available. All those are available from USC. But any pod that includes, for example, Palo Alto, I believe, or Cisco or others, I believe the institution has to have an agreement with those companies.
Okay. And no other questions right now, but I'll ask sort of another one. So for the research that Elie is doing, so far, has there been anything that you haven't been able to emulate with this, Elie? Have you had to sort of expand upon the initial model used for training at all to add in any new features, or was it sort of fully featured enough to do what you were looking to do?
It really depends on the idea or on the research project that you're working on. For example, we show a little bit of excuse me, software switches. Those software switches allow you to test, for example, your own protocol and see if the whole idea is working well. But if you're looking for performance evaluation, they are not enough. So what we usually do is we try to run the experiment here, see if it's working well, everything's working fine. And then it's just a matter of deploying our code to the real hardware and compare and see the performance there. So I would say the only problem is really performance, but it's just about those specific software switches, the P4 switches. As Dr. Jorge mentioned at the beginning, the OVS switches, when we ran the NTP or the high-speed networks experiments, they can go up to 40 or 45 gigabits per second. So it depends on the software being used. Other than that, I don't see any problem or anything that we couldn't do there.
Okay.
Jason, I'm looking at the chat window, Shafak Kfoury, and I can provide more information to him separate. I will leave my email if you want to contact me.
Yeah, that'd be great. And I'll also make sure that we put a link to your the lab infrastructure in the mail that we send out afterwards. And then I just have one last, more of a comment. We'll call it a question, comment, and also I'll poll the audience. I see a lot of familiar faces in the list here this week, so I'll call you out specifically for those of you that are running regional networks. Andrew, Brian, looking at you two. Would training of this nature be useful for your regional constituencies? We've already been talking with Cass down at SOX about potentially running a training event in the April-May timeframe to sort of allow his constituents an opportunity to play around with DMZs and perfSONAR nodes and DTNs. Is that something that is of interest to other regionals? Just in the general case, if so, just shout it out in the chat room and we'll make sure that we follow up with you afterwards. And then Shafak has another question, comment here. Twofold contribution, the development of hands-on labs and the platform itself. Why did you guys decide to build the platform instead of trying to use existing NSF-funded platforms for deploying and running these labs?
Yeah, thank you, Shafak, for this. That's a great observation because it's exactly like that, twofold. One thing is the development of field labs and the platform. The reason why we decide to build, and in fact, I want to give credit to the Network Development Group, our partners. We're using their technology for much of what we do. Other platforms are, this is my experience. Again, I might be wrong in the sense that I don't have experience with all the platforms out there, but the platform that I have experience with is a little bit harder to do these more complex topologies. And in particular, the topologies has to be, many of those are targeted to learners that are starting. So having a graphical interface where you can just click on the device and the device is open, looking at the topology in the screen, also making connections, all sort of connections that you wish. Also using the same IP addresses for all the pods running simultaneously are little details that at the end they add. I didn't find a platform that was easy enough, such as this one. And again, I have to give credit to the Network Development Group, which is our partner that they provide the platform. I mean, we are doing things together with them. We are developing this distributed cloud with the Network Development Group.
Okay. And it looks like a couple people have expressed interest in this, so I'll save that chat and we can link everybody up after the fact and see what would be possible.
Sure.
All right, I'm not seeing.
Yeah, Jason,
Go
I
ahead.
will be happy if anybody want to have access to these. Yeah, I will be happy to provide that access.
Okay. All right, I'm not seeing any more questions, so I'll give it one last mention. If anybody does have any others, please enter them in. But thank you, Jorge and Elie, for going over this information. Really, really good stuff. And for those who are still listening, next week's talk is going to be with Francisco Arena formerly from NIC Mexico. He actually just left to go to a different job, but he's still going to be giving a talk on Fort next week, which is a routing security platform. So I will send out the announcement about that later on, and no other questions. So thanks everybody for joining today, and I'll make sure I get these slides and links to the University of South Carolina infrastructure posted, and hope everybody has a great weekend.
Thank you.